Okay, so this is section 1.7. We're dealing with inequalities. Okay, the thing to remember on inequalities is algebraically, they're very similar to equalities. You're going to manipulate them very similar. Okay? Now, look, okay, add to your notes. Look on page 76, those rules, and the note on top of page 77. Okay, now when we solve inequalities, when you're solving a linear equation, it's very easy to do. You just find one value, but here when we solve these things, we're looking for, or we need to find all values that work. And it will be almost always more than one. Okay, graphs and number lines. Are good tools. Both to help you solve them and to help you understand what it is that you're doing. Okay, so let's work through an example of a linear inequality. Here I've got 1. This means less than. So what that means is that this quantity, 2x minus 4, remember this opens the bigger one, this quantity has to be bigger than 1. But I also have something over here, which means this inequality also has to be less than 7. So what you're dealing with here really are two inequalities. You've got this one over here, and you have this one over here. So what I'm going to do is solve this one first. I'm going to rewrite it so my variable's on the left. I've got 2x minus 4. Now I notice that this thing opens towards the 2x. So when I move it over here, it still must open towards the 2x. And then 1. All right, now I solve this. This is just like linear. I'm going to add 4 to both sides. I have 2x is greater than 5. Then you divide by 2. So x is greater than 5 halves. So what this tells me is that all the values I've got, only x values that are bigger than 5 halves are going to work. But that's just half of this. So now I'm going to go over, I'm going to work the area worked in blue, where I have a 2x minus 4 is less than or equal to 7. Again, I add 4, divide by 2. So I've got two answers here. So what this tells me is that based on this part, all my x values have to be bigger than 5 halves. But not only that, they also have to be less than, should be 11 halves. All right, so I know that my x values have to be bigger than 5 halves. That's from here. But they also have to be less than or equal to 11 halves. And for set builder notation, it's easy to do. You just do all x such that, and you've got this thing. Okay? This is set builder for interval. All right, since I don't have a less than, this is going to be a parentheses. So it's 5 halves. Then I go up to my upper end, which is 11 halves. And since that's an equal to, that's a bracket. So set builder, interval, and I'm going to actually work with this thing on a number line. So this is going to be 0, 1, 2, 3, 4, 5, and 6. Okay, so I know my leftmost point, x is going to have to be bigger than 5/2, which is 2.5. So x is going to be over here, but it's going to be an open circle, not a colored in one because it's not equal to. And then I go over to 11/2, which is 5.5. And that is going to be a colored in circle because it's equal to. And all values between these two are going to be my solutions. And that's how you solve linears. Okay, higher order ones. Again, are very similar. And higher order is quadratics and up. The important thing here is to make a table. Most students, I'm going to show you how to do this. Most students in the past who have tried to get away from making this step have had a terrible time getting these right. So let's work an example. X squared minus 3x minus 18 is less than or equal to 0. Step 1, factor. X is going to be x minus 6, x plus 3. Okay, now at this point we're ready to table it, almost. Let's go in and let's take a look at some critical points. Which are what makes each factor equal to 0. So I'm looking at this point. So my critical points are going to be where x equals to 6. That makes this term 0 and negative 3. All right. The second thing I want to look at is my inequality. We want things which are less than 0, which means we want negative numbers. Inequality we will pick up back at the end. So to make the table, here's what you do. I write down all of my factors. And then I come up here and I build a number line and I put in my critical points. So negative 3 is the leftmost point. It will be here. All right. And then I go over. So there's one interval. And then I come over and my next one is going to be at 6. So if you take a look, I need to test points. You determine what happens to it out here. You need to find out what happens to it in here. And what happens to it over here. So what you do, once you've got this table set up, is pick test points at each one of these 3 intervals. And it doesn't matter what the point is as long as it's in this one. So in this interval, the point I picked was a negative 4. Okay, it's less than negative 3. It sits over here. Now you don't care what the actual number is, just what the sign is. So negative 4 minus 6 is going to be a negative. Negative 4 plus 3, again, is going to be a negative. And then you need to look at the product of the two. So a negative times negative is going to give me a positive. Now, what I know is I'm looking for negative values. So what that means is that any x value in this range that's less than negative 3 is not going to be a solution. So those are not going to work. So now I come back into my second interval and I pick a test point. It's between negative 3 and 6. So I'm going to pick 0. And I plug it in. 0 minus 6, negative. 0 plus 3, positive. Positive and negative is a negative. There's what I'm looking for. So I know anything between negative 3 and 6 is going to be a solution. Now I pick a test point out here. I'll pick 7. 7 minus 6, positive. 7 plus 3 is positive. Positive and positive gives you a positive. So this will not work. And if you take a look at this, the nice thing about all of this is that it actually does give you a visual description about the intervals. So what I know here now is that x is going to have to be bigger than -3. Now I know I can include zeros, which means it can also be equal to a -3. But it's going to have to be less than 6. And because I'm including the 0, it can also be equal to 6. So my set builder is going to be x such that, that's that one. Okay. Set notation. Since this is equal to, it's going to be -3, comma 6. You put a bracket because it's equal, and you do that. So there's interval. And then we can work with the number line too, the graphical. There's 0, 2, 3, 2, 3, 4, 5, 6. Now I'm going to come over. I know -3, it's equal to, so I color it in. And I go over to 6. Again, it's equal to, so I color it in. And any value between here and here will satisfy my inequality and is the solution to this. All right. The last thing then I want to talk to you about are quotient or rationals. When you deal these, you're going to treat these just like the products in that you're going to have to use a table. But you're also going to have to deal with the quotients. Okay, so the best way to do this is let's actually work through an example. So we've got this. Now, like in the other one, we really want this to be 0. That's easy enough to do. I just subtract 1 over. So any non-zero term on the right side, you subtract over. I'm going to have 6 over x minus 1 minus 6 over x minus 1. It's going to be greater than or equal to 0. And the reason we do this now, I could come and look at this guy, and I could tell I'm interested in positive numbers. Okay, so we've got this. Next thing we need to do is find your least common denominator. In this case, it's going to be this denominator times this denominator times this denominator, which is 1. So my LCD here is going to be x times x minus 1. Okay, in order to get that up here, I'm going to have to multiply by x, so that gives me 6x. To get this one, I'm going to have to multiply by x minus 1. I've already got the x, so it's going to be 6 times x minus 1. And to get this one, I'm going to have to multiply by everything. It's going to be x times x minus 1. It'll be greater than or equal to 0. Okay, so now we distribute and simplify. So I'm going to have 6x minus 6x plus 6, negative and negative is a plus, minus x squared plus x. I notice 6x minus 6x, that becomes 0. So now I rewrite this thing. It's going to be over x times x minus 1. And you're still going to want to leave this in factored form. And I'm going to have a negative x squared plus x plus 6. It has to be greater than or equal to 0. Okay, just like on the other one, you're going to have to factor the numerator. So I'm going to have a negative x and an x. That gets me my negative x squared. I'm dealing with 3 and 2. And if you do this for the middle term, you're going to get 3x minus 2x, which gives me x, over x times x minus 1. So that is your factored form. It has to be greater than or equal to 0. And now we deal just like what we did before, where we make a table. So the first thing you do is you go in and you list all your factors. So I have a negative x plus 3. I have an x plus 2. I have an x and an x minus 1. So we need to find our critical points. And this is where it's going to be a little bit different. So what makes these 0? Well, 3 makes that 0. But this is in the numerator. This is in the numerator. This is in the denominator. And this is in the denominator. Anything which makes the denominator 0 is an asymptote, and you have to exclude it. Okay? So that's why we need these. So that and negative 2, these are from my numerator. And then my asymptotes for my denominator are going to be 0 and 1. Okay, so we do the same thing we did before over here. I've run out of room on the top, so I'm going to put it down here. The leftmost point I have is a negative 2, so I'm going to put that down here. Then I go to 0, and you notice these really don't have to be to scale. Then I go to 1, and then I go to 3. So in this case, I'm going to have to test several intervals. I'm going to go in and circle these two because those are not included in my solution. What the NI indicates. You don't have to put NI, but somehow or other, you need to remember that these 2 points are not included because they make the denominator 0. Okay, so again, I go in and I pick a test point over here. Test point I picked is negative 3, and I plug it in. Okay, so a negative with negative 3 is a plus 3 plus 3. That gives me a positive. Negative 3 plus 2 is a negative. Negative 3 is a negative. Negative 3 minus 1 is a negative. So here I come in. Remember, these are my nominators. So negative, a positive times a negative gives me a positive. A negative times a negative gives me a positive. And I need my result down here. Okay, so I've got a positive and a positive. A positive divided by a positive gives me a positive. And I know, because I did it before, that I want a positive result because it was greater than 0. So anything less than negative 2 whoa, I messed up. Came out of nowhere. And positive times a negative gives me a negative. So this is going to be a negative. Negative divided by a positive is a negative, so I know this interval right here is not included in what I'm doing. All right? So now I pick a point between negative 2 and 0, and I'm going to pick negative 1, and I plug it in. Negative 1 plus 3 gives me a negative, positive. Negative 1 plus 2 is a positive, so these two products are going to give me a positive. And then I come down here. When I plug a negative 1, this is negative, this is negative, a negative and a negative gives me a positive, so my net result is a positive. So I know that this interval is one of them I have, and I put this guy down here, so I know it is not included. So now I get a test point between 0 and 1. I picked a half. Gives me a positive, 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 and a negative. These products are a positive. These products are a negative. Positive by a negative gives me a negative. So this is not included because I needed a positive. Okay, then I pick a point between 1 and 3. There's an obvious one. 2. Pick whole numbers if you can. You plug it in here, negative 2 plus 3 gives me a positive. 3 plus 2 gives me a positive, 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 positive gives me a positive. So again, I know this interval is included, except I cannot put in this point because it's an asymptote. The last one I need to pick is a point out here. I picked 4. That gives me a negative, positive, so that product is a negative. It's my numerator. Positive, positive, negative, positive is a negative. So that point is no longer allowed. So we come back in and we write our solution. Looks a lot like domain and range. So I know it's between these two. So x is going to have to be bigger than negative 2. But because it can also be equal to 0, I allow that in. But it's going to have to be less than 0. I cannot include that point because it's an asymptote. Okay? And then you union that with this point. You don't allow it to equal 1, it's an asymptote, but it can equal 3 since that's allowed. So now we can do our set builder. We can also do interval notation. Since I did include negative 2, it's going to be a bracket. Negative 2, comma, 0 is not included. And then we union that with 1, which is not included, so it's parentheses, and 3, which is included. And on the number line, zero. All right, we know we come in, we've got negative 2, but it's not included. 0 is. So anything in this interval is a solution. Then I go over here to 1, but I don't include it. Then I go over to 3. So anything in this one is also a solution. Okay, the last thing you're going to have to remember to do, add to your notes, page 81 for absolute value inequalities. And that's how you're going to do this section.